Good morning, afternoon, evening, everyone. Welcome back to my channel, The Simple Architect. Thank you for joining me today. We are here to explore an exciting solution that integrates real-time data from Salesforce with Snowflake, leveraging the power of Confluent Kafka Connect and Snowflake's dynamic tables. To set the stage, let's talk about the problem we are solving. Modern organizations rely heavily on real-time data to make critical decisions, and Salesforce, being one of the most widely used CRM platforms, is often at the center of this ecosystem. However, Salesforce data integration can be challenging when dealing with two distinct types of data stream. Bulk data, large volume of data pulled from Salesforce using the bulk API. Change data capture, real-time event-driven updates sourced via Salesforce Streaming API. The challenge these two data streams pose is that they are structurally different. The bulk API payload is optimized for high-volume data extraction, while the CDC payload is optimized for granular event-based updates. These differences make it difficult to work with the data in a unified and meaningful way, especially if your goal is to provide accurate insight in real time. We have designed a data integration pipeline that addresses this challenge by using Confluent Kafka Connect to source both bulk API and CDC data from Salesforce, leveraging a Snowflake sync connector to ingest this data into Snowflake, and most importantly, unifying these two structurally distinct payloads into a single cohesive object using Snowflake dynamic tables. By the end of this presentation, you will gain a clear understanding of how we integrate Salesforce data streams using Confluent Kafka, the role Snowflake's dynamic tables play in unifying the two payloads, and how this solution can help your organization leverage Salesforce data more effectively for real-time insight. In summary, our goal here is to simplify data integration challenges, deliver real-time unified data, and ultimately empower better decision making. Let's dive and take a closer look at how this solution works. Thank you, and let's get started. How it works. This is a high-level overview of how the solution works. In Salesforce organization, we enable change data capture, CDC, for specific objects, account contact, leads, etc. Event generation, when records for those enabled objects are created, updated, deleted, or undeleted, Salesforce generates a change event message that is written to the event bus. Confluent Kafka site setup, a Salesforce CDC source connector configuration from Confluent Kafka that subscribes to the appropriate Salesforce streaming channels, change event channels, to receive this notification or events created, updated, deleted, or undeleted. A Snowflake sync connector to write the messages from the Kafka topics into a Snowflake table. A Snowflake site setup. In a Snowflake is where we create the dynamic tables to unify the data from both objects, bulk and CDC API. This slide provides a high-level overview of the solution architecture for integrating Salesforce data into Snowflake using Confluent Kafka as the hub. The primary goal of this architecture is to unify structurally different payloads from Salesforce bulk API and a streaming API into a single coherent object in Snowflake using dynamic tables. The key components is the Salesforce event bus. The Salesforce publishes two types of events, bulk data via the bulk API, representing the complete snapshot of the data, the change data capture events via the streaming API, representing incremental updates. Confluent Kafka Connect, a CDC connector, and a bulk API connector ingest these events and publish them to Kafka topics, and the Kafka topics, you name it accordingly. Underscore snapshot, underscore change event to separate them. Snowflake Sync Connector, the Kafka Sync Connector pushes these topics to Snowflake for storage and further transformation into dynamic tables. Snowflake dynamic tables. Within a Snowflake, the incoming data is stored in a database. And you can see we have two tables that they match or they mimic what we have in the topics. Underscore snapshot for the bulk data and underscore CDC for the CDC updates. One thing I like to mention that in this slide, I'm not showing the actual unified object using the dynamic table. That will come later. Solutions architecture overview continue. So this is a little bit more detail, right? To unify the snapshot API and the CDC payload into a single table while preserving history and handling the partial update from the CDC payload, we need to implement a solution that, number one, handle partial updates. Only the fields that are updated in the CDC payload will have values, while the rest will be null. The unified table must merge these changes with existing snapshot data. Preserve history. Maintain a record of changes for audit logging or rollback purposes. And use hash key to detect changes efficiently and avoid unnecessary updates. And obviously automate the refresh process to use Snowflake dynamic tables to ensure the unified table is updated automatically when new CDC data arrives. This is the high-level solutions architecture using Snowflake dynamic table. The solution leverages a Snowflake dynamic table to process and unify Salesforce data into three key objects. And here's how each dynamic table contributes to the overall architecture. And think about this as an assembly line. It works that way. So you have the unified data that combines the snapshot data from the bulk API and the incremental updates from the CDC stream into a single unified data set. And the key features is merges the contact or snapshot and the contact CDC table, adds an event type column to distinguish between a snapshot and CDC events, and ensures that all incoming data is aligned with a consistent schema. Then you have the transformed object. And the purpose of the transform object basically is applies additional transformation to the unified data, including forward fill logic and record hashing for the deduplication. And some of the key features that implements the forward fill logic is to handle missing or delay CDC updates and creates record hashes to identify and flag duplicate records, ensure data consistency, and prepare it for final deduplication. And the output of that is a clean transformed dataset ready for deduplication and historical tracking. And the history object or the history table produces the final deduplicated dataset, maintaining a historical record of all the changes. And some of the key features is deduplicates records based on the calculated hashes, maintain a historical log of all changes for auditing and analytics, and provide a single source of truth for downstream application. And the output of that is a really nicely deduplicated historical data set that can be queried for real-time insight or batch analytics. And in my next presentation, I'm going to get into the nitty-gritty detail of how this dynamic tables are put together. So we're gonna look at the code. Thank you for watching, and if you like it, subscribe to my channel. Please join me in part 2 of this presentation, where I'm going to do a deep dive into the technical implementation. Thank you very much. Have a wonderful day.